Hello, I am Shantanu Bhattacharya, and today I would be talking about the digital identity fraud. So, first of all, what is digital identity fraud? When anybody goes on the internet to, you know, visit a website, visit their a bank or anywhere else, there is a need at times for entering username, password, and in addition to the username and password, a second factor authentication mechanism like what most banks and large retailers require. And what I mean by second factor authentication is like a SMS text message with a number which you have to enter when you try to enter the website or the bank site or the bank app. Or, for example, you would have a hardware token and there is a number displayed on that hardware token which you have to enter before you can be provided access. This same hardware token is sometimes available in software as well, wherein you actually have the number displayed in the mobile app, and that app's number is then to be entered into the website before they give you access. Other such solutions could be using your own biometric, like, for example, fingerprint or iris scan or face scan and things like that. There are many human biometrics which can be used. So the digital fraud, digital identity fraud actually is about somebody else posing as you and successfully doing that at that, and then accessing your details or your websites, your accounts, or anything else, and thereby causing you some harm, either reputational harm or financial harm or anything of that sort. That's what I mean by the digital identity fraud. And what you would notice here is that in any of these kind of transactions, the problem is you are not there face to face to actually present yourself. So somebody looking at you and sort of saying that, yes, it is you are presenting yourself. And then in certain cases, when you try to do an FPOS or any financial transaction, you sometimes present your physical credit card. Now, that physical credit card generally has some security mechanisms like chips and things like that in many countries nowadays. So that provides some amount of security and some amount of um, you know, trust in that particular transaction. There are people who even clone your credit cards and present them and things like that, but that's not what we are talking about here. So here we are specifically talking about the scenario where the internet transactions that you perform is actually defrauded by someone and causes harm to you. Now, don't get me wrong, there are certain scenarios where you would like to be anonymous when doing a particular activity on the internet. For example, if you're trying to do a Google search, why would you think anybody wants to figure out who you are when you're doing a Google search? But that's not what I'm talking about. I'm talking about scenarios where there is a harm caused by posing as someone else. So that's the problem of digital identity fraud. Now, we have also seen some of the solutions that there are. I will be talking about some other solutions as well. So what is important here to note that whether it be a human or whether it be a machine, when it tries to communicate on the digital platform or a digital internet, they need to use a hardware, whether it be the mobile phone, whether it is the laptop, whether it is a PC, whether it is some other electronic device, like an iPad, for example. So everywhere, the front-ending thing or the front-ending entity is an electronic device. And now, what I'm going to talk to you about is a new way of solving this problem. But why do we need a new way of solving this problem? Because I don't know whether you're aware, but the world economy is spending about 170 billion US dollars per annum to solve this problem every year, and it's increasing every year. But in spite of that, every year the world economy is losing 550 billion US dollars. And therefore, there is still an opportunity to think about this problem in a different way and solve it so that this $550 billion can be reduced greatly or significantly. So imagine a situation where your device, which is actually the entity front-ending your internet or the digital transaction, has a unique identity in itself. And it is so accurate that it is very difficult to then replace it by some other device. So what I mean by that is, for example, consider a mobile phone. Mobile phone has a lot of hardware sensors, which are analog in nature, like, for example, accelerometer, gyroscope, magnetometer, and things like that. And by the virtue of the way it is manufactured, there are some inaccuracies left in the manufacturing process. So I'm not talking about a new manufacturing process. The existing manufacturing process actually leaves some imperfections, and thereby you can actually identify the hardware device uniquely using that. And when you can do that, and this technology can actually give you 1 in a trillion or 1 in a even quadrillion or even better accuracy. Now, compare that with the accuracy that you get in the existing solutions that I talked about. So for example, let's say the one-time password, which is the SMS text which you get with a number which you have to enter. And that is generally a 4-digit or a 6-digit number. But the problem with that is, or even the software token, is that it assumes the device which receives this information is the rightful device. But did you know that a mobile phone can be hijacked completely remotely without having a physical access, and thereby the actual rightful owner doesn't even know that an SMS text has been sent or a mobile app data has been sent. It goes directly to the attacker. And these attacks are actually becoming more and more sophisticated by the day, and that's become a problem. Now consider what happens if you had a hardware token like the RSA token that we talked about. Now if you have a hardware token, it is very good, it is pretty strong and things like that, but you would have to now manufacture the token, you need to distribute the token, you need to replace the token if there is a problem with the token, or you need to trace a stolen token and things like that. So it can be very expensive. Now let's look at the human biometrics. One of the best known human biometrics is iris scan. Now, iris scan itself, the false acceptance and the false rejection rate is of the order of 0.99%, which actually leaves a high, room for improvement in terms of the accuracy. And so what happens then is the technology that I talked about, where you actually measure the accuracy of the hardware characteristic, you get about 1 million, 10 million, or even 1 billion times more accurate. So that's the kind of difference that you will be able to get with the new technology. And the new technology, by the way, is called as silicon biometrics or device biometrics, because it's like the human biometrics, but for electronic devices. And that's what I just wanted to discuss today. Thank you very much.